All right, in this video, we are going to quickly review density. So I know density is something that you have talked about before. Density would be, for lack of a better word, how much stuff we have in a given area. So something like a brick is going to be very dense compared to a pillow because a brick's going to have more matter in there in a given volume. Our density calculation is density is equal to mass divided by volume. And that formula is on the back of your reference tables. So you probably already know it, but if you happen to forget it, it is on the back of your reference tables. We do need to know that the density of water at 25 degrees Celsius, which is just a tiny bit above room temperature is about 21, 22 degrees Celsius, is 1 gram per milliliter. That's important because if we have something like 25 milliliters of water, it would have a mass of 25 grams since the density is 1 gram per milliliter. Now, we also are going to use reference table S for the density of various elements. So if you look on that last page of the reference table where the elements names are given, density is also given, and those measurements are at 25 degrees Celsius. It, some questions you'll see things talking about STP, that means standard temperature and pressure, so normal conditions. All right, so first question says, which element has the highest density at STP? Again, STP means standard temperature and pressure. And I'm going to actually change this question a little bit. I'm going to leave it standard pressure, which would be 1 atm and 25 degrees Celsius, so that we can use table S because standard temperature is 0 degrees Celsius. So to be exact, we should have this one be 25 degrees Celsius. So all we do is we look up the densities on reference table S. So you look up neons, that's atomic number 10, and that density is very low. It's 0.000825. So that is probably not going to be our answer. Sulfur's density. Sulfur is atomic number 16. That has a density of 2 grams per cubic centimeter. Cobalt, that is CO, and atomic number 27. The density for cobalt is 8.86. So that is pretty dense. So I'm guessing that's probably going to be our answer, but we are going to do our due diligence and check them all. Rubidium, atomic number 37, is 1.53. So cobalt is going to be our answer because that one has the greatest density. All right, now we just have some basic calculations. So our first one, a rock has a mass of 3.5 kilograms, volume is 7.0 cubic meters. What is the rock's density? So density is mass divided by volume. So our mass is 3.5 kilograms. The volume is 7.0 cubic meters. I do want to see substitution with units. 3.5 divided by 7 is 0.5. But we do need significant figures. 3.5 has 2 significant figures. 7.0 also has 2 significant figures. So our answer needs 2 significant figures. So we have to put the 0 at the end. Then we also need units. Units are going to be kilogram per cubic meter because we did kilograms divided by cubic meters. All right, example number 2. We have an object with a density of 8 grams per cubic centimeter. So we have 8 grams per cubic centimeter for the density. mass is 1.5 grams, and volume is our unknown. I like to leave my unknown as V instead of X because then it reminds me that it's volume. I make sure at the end I have a unit that makes sense, but if you want to put an X, you certainly could. When I'm solving for an unknown in the denominator, I first cross multiply so that I have a linear equation. So if I cross multiply, I get 8.0 grams per cubic centimeter times V is equal to 1.5. So then it's easier for me to see I am going to divide both sides by 8 in order to get volume by itself. So I'm going to do 1.5 grams divided by 8. So I'm going to get a number less than 1, and that is perfectly fine. It doesn't matter. So 1.5 divided by 8 is 0.1875, and grams would have canceled, so cubic centimeters would be my answer. But I still need to do significant figures. That had 2, that had 2, so my final answer needs to have 2. I'm somewhat running out of space. This is going to be 0.19 cubic centimeters, because that would give me 2 significant figures. All right, we've got 2 more. So what would be the mass? So we're looking for mass. 25 milliliters, so that's going to be volume, and density is 0.047. So again, my density formula. So I have density, and I have volume, 25 milliliters. So I'm looking for mass. Put that over 1, cross multiply. So mass is going to be the 0.047 times 25. So I'm going to put that into my calculator. And that gives me 1.175 grams. Now I got to do significant figures. 2 significant figures. That one also has 2 significant figures because that first 0 wouldn't count as a significant figure. So my answer can have 2 significant figures. So it would be 1.2 grams, because basically I'm going to keep those 2 digits, but then there's the 7. So it will round up. All right, last one. What would be the volume? So we are solving for volume of a 15.2 gram sample of aluminum metal at 298 K, which would be 25 degrees Celsius. So we are going to use the table. So first thing we do is we find aluminum on table S, and we find its density. So aluminum's density is 2.70 grams per cubic centimeter. So now it's like all of our other problems. So you had to go to table S and find aluminum's density. Density is mass over volume, so it's equal to 15.2 grams divided by the volume. Put that over 1, cross multiply. I get 2.70 grams per cubic centimeters times V is equal to 15.2. Once I do that, I can see I'm going to divide both sides by 2.7. So I'm 15.2 divided by the 2.7, and that gives me, for volume, 5.6296. Significant figures, that had 3, and this had 3, but actually that came off the reference table, so you can treat it as a defined value. So we are going to have 3 significant figures in my answer, 5.63 cubic centimeters.